Welcome back, everybody. We're still talking about division of radical expressions. So everybody, let's talk a minute about fractions. If I have the fraction 15 over 20, would that be an acceptable answer? Good. No. We all know when we deal with a fraction, it has to be in lowest terms. It has to be reduced. So 15 over 20 would have a GCF, a greatest common factor of 5, and when we divide it by that, our fraction would reduce to 3/4. Well, we're going to use this same arithmetic concept when we deal with radical expressions. If there is a fraction inside your root symbol, inside your radical sign, before you actually go and do any division, you can reduce that fraction first and simplify it to make it easier to do the square root process. So let me show you an example. If you look at your PowerPoint, my expression is the square root of 18 over 50. So everybody look, I have one square root symbol, and inside it I have a fraction, a rational number, 18 over 50. Now, I could take that radical sign and give it to the numerator, write square root of 18, and then give it to the denominator and give it to the square, write a square root of 50. But I don't want to do that. What I want to show you is if we follow, please excuse my dear Aunt Sally, so we're supposed to work inside this grouping symbol first. And if there's a fraction inside the grouping symbol, can't we reduce it? And we all know 18 and 50 have a greatest common factor of 2. So if I follow order of operations and rules, I would take that fraction, 18 over 50, and I would say, all right, let's divide both the numerator and denominator by 2. 18 divided by 2 would give 9. 50 divided by 2 would be 25. So now our radicand inside the radical sign is 9 over 25. And we all know that fraction's in lowest terms. So now our expression is square root of 9 over 25. But we can't leave that. You can't leave a fraction in a radical sign. You need in your radical sign a whole number. So now we already know this. We know when we have a fraction in a radical sign, that means that root symbol belongs both to the numerator and the denominator. So now I can rewrite this as the square root of 9 and the square root of 25. And what do you know about both the numbers 9 and 25? Very good. They're both perfect squares, which means that we can now do the square root operation. We all know the square root of 9 is 3. We all know the square root of 25 is 5. So this expression simplifies to be 3/5. So if you look in the beginning, you can't do the square root of 18 because it's not a perfect square. We couldn't do the square root of 50 in the beginning because it wasn't a perfect square. But by reducing that fraction inside, by following order of operations, we were able to reduce the fraction and now get perfect squares that we could square root. Now, there is another way to work that expression to get that value. And it wouldn't be wrong. It still is mathematically correct. It's just more work. So if you look at your PowerPoint at the bottom, it shows you. If I have a fraction in a root symbol, we've already discussed, you give that root symbol both to the numerator and the denominator. So I rewritten the square root of 18 divided by 50 as the square root of 18 divided by the square root of 50. So I didn't reduce the fraction first here. I left the fraction alone and just split it into 2 square roots. 18 and 50 are not perfect squares, but I can find a perfect square in each one of them. If I look at the number 18, its perfect square is 9, so I could rewrite the square root of 18 as 9 times 2. In 50, its biggest perfect square is 25. So I could write the square root of 50 as the square root of 25 times 2. Now I can do the square root operation. In the numerator, I know the square root of 9 is 3, so the 3 comes out. I cannot perform the operation on 2. I cannot do the square root of 2, so it stays inside the symbol as the radicand. In the denominator, I can do the square root of 25, which is 5, so the 5 comes out. Again, I cannot do the square root of 2, so the 2 stays inside as the radicand. So now if I look, I have 3 square roots of 2 divided by 5 square roots of 2. 3 square roots of 2 is connected by multiplication. It's a monomial. 5 square roots of 2 is connected by multiplication. It's a monomial. Therefore, I can divide. In the numerator and the denominator, I have the same term, square root of 2. It divides out, and it gets me my quotient 3/5. Now you tell me which way was quicker and easier to calculate. Was it easier to reduce the fraction first, or was it easier to make 2 square roots and simplify? And if you're like me, you realize if you take the fraction inside the root symbol and reduce it first, your work is going to be less. So let's go practice that now on the whiteboard.